Hello, Sacke here, back with another Genshin Impact video. Today, I will be doing the follow-up to my most recent video, how to measure distances in Genshin Impact. So, first of all, I would like to thank you all so much for the great reception that this video has gotten. It is my second most popular Genshin video as of the time I'm recording this, and well, I can't thank you enough. So, for this follow-up, I want to go into a new methodology for measuring the player speed, as that is something I needed to do in order to measure distances or calculate distances, is to use the player's speed. And well, I did have a methodology for measuring the player's speed last time. However, I would say it's probably not the most accurate, nor the methodology is the best way to do it. Another problem with using this quest is that the quest navigation, the one that we use for like the navigation, it doesn't exactly update in real time. So I can't exactly see how far the player is without like slowing down. In this video, I'm going to be showing you a new method, and with the help of a comment brought up by a wonderful person called Hadrol3405, they brought up the leisure device Twang-Bang-Bang minigame in the Teapot. This minigame can be purchased from Tubby, and you can go to the Realm Depot, go to Riches of the Realm, and you should be able to find it here. I've already purchased it, so it's sold out, but you can purchase it from here. So basically, if you've ever seen those like minigame primo jet, those things where you're required to shoot exploding barrels, well, that's exactly what this is. This minigame is the Teapot equivalent of that. So I'll just go over to this one over here to, well, set it up for you. Oh, that one. Wrong one. This one. To show exactly what it is. So, as you can clearly see, it's just the shoot the exploding barrels one. Now, what's so great about it? The amazing thing, if you haven't realized, is that the distances to each barrel is actually shown. And not just that, the distances update in real time. So I can see how long it takes to travel 1 meter distance. 1 meter displacement, I should actually say, because the distances or the values you see here are actually displacement relative to the player position. I mean, yeah, the shortest path distance to it, or a straight line distance to it. That's what the distances are shown are. So that's very, very, very useful because it can allow us to, well, see how long it takes to travel 1 meter, and it also just helps prevent like maybe making some misconceptions. Like, for instance, maybe I'm not exactly measuring 6,532 meters away. I don't know. It can be a little misleading because you don't have decimal places. You're only given a rounded integer. Now, I have divided this in my Teapot is been set up in such a way that I can very easily see how things go. One thing I found pretty useful is that I think the grid in the Teapot is actually in increments of 1 meter. Now, I'm not exactly sure which size it is, but maybe this size is 1 meter. If you scroll all the way in, I'm not sure this is a meter. This might be half a meter now. So this should be 1 meter increments, I think. I think those are 1 meters increment. Now, another thing that's great about the Teapot is that if I place like stuff on, what the heck are you doing? Okay, we can also, dude, chill. Okay, so I can now also see the heights of things. So right now, this platform height is 2.5 meters off the ground. My guess is that that's the distance from this surface to the ground. But I can also raise this platform, and then I can also see, hey, this is pretty much 10 meters off the ground, and that's pretty great. So I can now actually very easily see the heights of things. Another thing I'm making use of for the Teapot is these teleport waypoints. Why are they positioned where they are? Well, the ones that are importantly positioned are this one and this one. The one on top here is not as important. The reason why I position them, I'll move this one over here, is because we could very easily use them as a way to make a consistent setup. So notice here, I'll teleport to this teleporter. Now I'm going to change my angle. I'll do like this, and then I'll teleport back to it. Notice something? Yeah, I'll try doing this again. The great thing about these teleport waypoints is that they will always make you face a specific direction, depending on how you place down the teleporter. So how it works is that you will always face like 45 degrees, it will always face in the 45-degree angle away from it. Yeah. So because we know that, we can now actually find a very easy way to make us a good and consistent setup. That also allows us to eliminate having to properly, center, make sure my camera is properly aligned, things like that. So now I can just all I need to do, go to teleport, make sure not to move my mouse, and then I can start the game like so. And I can very easily see, oh, it takes that long to travel 1 meter distance. And yeah, that's the amazing part about this. So, and if I want to change my setup, well, I can change the teleporter. For instance, maybe I want to measure how I would want to measure the gliding downward speed, the downward gliding or the falling gliding speed. I can very easily do that. Now, this one I don't have a teleport that perfectly positions me. And the reason why is because I'm kind of lazy to position it. And two, I just make use of this barrel. This one doesn't require the utmost precision sort of thing. So I could just jump off and see, hey, wait a minute. There's the barrel, and I can see how long it takes to travel 1 meter downward. You can see I'm falling straight downward, pretty much towards the barrel. Might fall up on the edge of it, but you get the point. There we go. And for the last one, which is right here, I'll go ahead and exit the challenge. You cannot teleport without exiting the challenge, unfortunately, but that's just how it is. I can move this right here, position it right there, and that will be for this barrel. For this last one, I do also need to bring up a bit of math as, are you kidding me? Okay, you might have saw that my camera screen kind of just very slightly jolted to the side. I'm not sure if that's because your mouse very slightly moves, but I noticed that if you try to move your mouse over a bit, it will eliminate that. So here we go. So you can see here, this platform is about 10 meters high off the ground, and then we can also jump into the air and open our wind glider to see the time it takes to land on this barrel, or you can also see how long it takes to travel the diagonal distance. You're traveling in distances of diagonally 1 meter. Now, the thing is, from doing this test, we actually want to measure the horizontal distance, we want to measure the horizontal traveled distance. So this one, we need to do a bit of math for it. For one, when I jump into the air, it's about 35 meters diagonal distance. I do jump into the air just because I just want to do it that way. Yeah, so you can jump into the air, open the wind glider. It's about 35 meters. Now for the height, I did say it is 10 meters up to this platform. However, I do think the player does jump. When the player jumps, well, obviously that gains a bit of height. I don't know what exactly it is, but the point is you jump up and you go up about 0.5 meters. So let me go ahead and head over to a drawing program right here and try and do the math. Enough about that. So we have our triangle here, our right triangle. have our triangle here. It's a right triangle, so we can very easily, it makes things all nice and neat for us. So we know that this height is, well, more or less 10.5 meters, and the 0.5 is from the height gained from jumping. So this is approximately 10.5 meters into the air. And I think it also is pretty safe to say that this diagonal distance here, let me give myself some space. This diagonal distance, this one is about 35 meters away. And we can very easily calculate that by using Pythagorean theorem. So and well, from this we get approximately 33.38, approximately that much meters. Now, the thing is, would like to measure the distance that's traveled in a meter. So when you travel a meter like this, 1 meter, we want to know how far horizontally we travel, because that's what we're interested in. We want the horizontal distance traveled. So that's what we're interested in. We want to measure this distance, x. Well, luckily for us, this is actually something that we can actually make use of something here. If you notice, we can actually kind of cut out this little, very, very little tiny triangle right here. So we have our triangle here, and we can just make it much larger. And we know this diagonal to be 1 meter, but we also want to know what this horizontal distance is, which we call x. If you know anything about this, we can make use of something called similar triangles. Similar triangles is, well, just the result of, well, the slope of the line being generated by these triangles just kind of being the same side. It's a very interesting thing. But the point is, because of this, what we can do is make a ratio between the original size and the new size here. So we could say 1 meter. 1 meter is also, the 1 meter ratio is equivalent to the 35 meter one, but this is also equal to, well, on our scale of 1 meter, we also have the x. We have x, and then we have, well, our base is 3.3. Well, I'll put it as b, and we have b for our base. So yeah, you can see the ratio here. So we have 1 is to 35, and then we have x is to b, which is 33.388 meters. And well, I think you can see what we can do here from now. We can actually isolate what our b is. We can solve for x, we can multiply by b, and well, it's simply b divided by 35. So that's our distance if we base it off of a distance traveled of 1 meter. So that's the amazing part about this. We can very easily calculate this. And well, if I go to my spreadsheet, this is exactly what I'm calculating. When I travel a diagonal distance of 1, I can very easily calculate the horizontal distance and the vertical distance, you name it. So that's the math part on this one. It's not too hard to understand, I hope. Though, yeah, it just makes use of similar triangles to determine the horizontal distance traveled when you travel a diagonal distance of 1 meter. So that's what it is. And well, after going through all of those numbers, well, we arrive at something. We now can arrive at some new set of numbers. Since last time we noticed that the glide falling and glide horizontal speeds were the same regardless of the character model, or they are approximately the same. I didn't calculate. It didn't really matter based on which gender and model it was. I just calculated the speeds. So we can see here that for the tall male model, it is obviously the fastest. Um, so yeah, that's pretty clear. So we still see the same general trends. So we have our tall male. It moves just a little bit. It moves a little bit faster than the tall female, and then the tall models move faster than the medium models, and the short females are the slowest in this. So yeah, I also still see that trend where the tall female has the largest or has the biggest walking speed. It's not by a huge margin, but I still notice that it's they're just a little bit faster, just a little bit. And for this, I also decided to put the estimated actual speeds of everything is. So the horizontal and glide falling, they seem to be very close to 1.9 and 6 respectively. So that's actually pretty cool. I'm still unsure about the walking and jogging speeds. But I did estimate these values, and I do think that there probably is a specific ratio between a specific walking to jogging speed or jogging to walking speed ratio. So you can see here that I took the walking speed and divided it by the jogging speed. They're all pretty close to each other. And if you look at their average, let me take a look at their average. It's pretty close to 0.2. I have a feeling that that's what it is. Because in coding, it kind of makes sense from a programming standpoint to just have be a constant slower than everything. But at the same time, that wouldn't lead to the tall female being faster. So then again, maybe I'm just reading into things that shouldn't be there. But in the end, we do have, I think it's best to just use these values for the walking and jogging speeds. Yeah, so we have these, and then we have these for our gliding and horizontal speeds. I think the 1.9 and the 6 are pretty close. So I think it's pretty safe to say that it's a good enough approximation. Now, I do also want to talk a bit about something, the calculus of it all. For the longest time, I struggled to find a good way to teach the calculus. My thing is, without making the video like extremely long, I struggle to find a way to teach calculus because there's quite a lot of background needed for it. So I'll open up my screen here again. Under calculus, we have our basics. We have typically it's taught like this. You have limits, then you're taught derivatives, then you're taught integrals after that. After integrals, you're taught some basic differential equations. And this is just the general flow that you see. The things that we were seeing in the last video were actually differential equations. But differential equations requires you to already know pretty much all of this stuff here. Well, limits is kind of required to understand, or not really required, but it's kind of the foundation for derivatives and integrals. So in a sense, you kind of have to like teach an entire, pretty much multiple semesters worth of topics in order to actually properly explain it. I have a hard time trying to see how I can actually teach these things, all of these things. It does feel awkward because I do feel like for a lot of things, at least a lot of things in physics, calculus and physics are almost very hand in hand. That's why I'm not sure how to teach it. But anyway, yeah, that's really about it for now. So thanks for watching and hope you've enjoyed.